Hello and welcome to our lesson on rates of change. So what is a rate of change? Well, a rate is describing how one quantity changes with respect to another. So one quantity changing with respect to another is precisely what a rate is. And I'm going to show you an example in just a second here. If we're talking about something called a unit rate, then what we're looking for is going to be an average rate that indicates how one quantity is changing with respect to one unit of another, so usually over a longer period of time. So let me just show you an example to wrap your brain around these couple of concepts, okay? So Kyle logged the numbers of hours he slept each night last week in this chart. Monday he slept 7 hours, Tuesday 8, Wednesday 9, and so on. So at the end of the week, there was a total of 56 hours that he had slept. So there's a couple of different ways we could describe a rate for this situation. So for the week, we could say he slept 56 hours per the week. Okay, so we could say 56 hours per 7 days, or 56 hours per 1 week, or whatever. And we could also write this as a fraction. 56 hours per 1 week, like this. So we can replace the word per with the fraction bar. All right, and so that would be two ways we could give this rate for the week. Now daily, we could actually average this out. If we took the 56 hours and we said 56 hours per 7 days, 56 hours per 7 days, a little off center, that's going to bother me, and we made that a fraction, then we could take the 56 hours, divide it amongst the 7 days, and we could say that that is an average of 56 divided by 7 would be 8 hours per day. Okay, so we know he's not sleeping 8 hours every day or each of the nights, right? It ranges 7, 8, 9, 8, 6, 10, 8. So it ranges there. But if we added them all up to get that total of 56 and divided it by the 7 days, we would average that out to what we call a unit rate of 8 hours per day. So the unit rate is going to be our average. And the unit rate, again, is going to be the average rate, okay? But saying 56 hours for the week is still a rate. Saying 57 or 56 hours for 7 days is still a rate. When we average it out, even though, again, we don't know, or we actually do know that he didn't sleep an exact 8 hours per day, that 8 hours per day average kind of represents that entire week, okay? But the general concept that we're looking at here when we're finding these rates is we're looking at two quantities, and we're going to divide to figure out the actual rate of change between those two quantities. So in general, to calculate rates, we divide our related quantities. So 56 hours here, let me go back to this one. In 1 week, we could say is 56 hours per week. Okay, and then if we divided that out daily, again, we're going to replace that word per with our divide symbol to calculate our rate. So let's look at a few more examples here. It says that Brooke drove 300 miles on 10 gallons of gas. Express this as a rate and a unit rate. So 300 miles on 10 gallons. That's going to be 300 miles per 10 gallons. And that would technically be a rate, 300 miles per 10 gallons. So the exact information they give us is a rate. Now if we want the unit rate, then we're going to divide that down. And 300 divided by 10 is going to be 30. So this ends up being 30. And then it's going to be miles per gallon. So the unit on the top of the fraction is the unit that goes first in our answer. So it's 30 miles. And then per is, again, divide per gallon, like this. And actually miles per gallon has an abbreviation that's commonly used, so we could also say this is 30 miles per gallon, mpg. You've probably seen that before. So if I said express this as a rate, you could literally write exactly what's given to you, and then the unit rate averages that out. So the unit rate is an average of 30 miles per gallon. Now, we don't know that that's true, right? It could be that there was 40 miles traveled for the first gallon and there was 20 miles traveled for the next gallon, but on average, 30 miles per gallon. Okay? Let's try that again. So Scott spent $585 to stay 3 nights at a hotel. Express this as a rate and a unit rate. So $585 per 3 nights. Okay, that would be a rate. It's given to us as a rate. If we divided this out, we're going to get the cost per 1 night. So what is 585 divided by 3 would be the next question. I'm going to use my calculator, and that's 195. So if we divided this, we get 195, and it's going to be, again, the top unit per the bottom unit. So it's dollars per night, and we're going to say dollars per night. Okay, so it's given to us as a rate. We're just making it a fraction, and then we're going to divide to find that average unit rate. All right, Angela read 560 pages of her book over the last 5 days. Express this as a rate and a unit rate. So 560 pages over the last 5 days. That is a rate, and if we divide 560 by 5, that's going to be an average of 112 pages per day. Pages per day. Okay, not so bad, hopefully. Let's see, Janet worked with a tutor from 1:30 to 4 p.m. to complete 300 math problems. She paid the tutor $43.75 for the time spent. And first it says, how much was the tutor paid per hour? So here, from 1:30 to 4 p.m., that is, let's see, from 1:30 to 2:30 to 3:30, and then to 4 is 2.5 hours. So 2.5 hours spent here total. 300 math problems completed, and then $43 spent for the time. So the first question here says, how much is the tutor paid per hour? Paid per hour means we're looking for money divided by hours. Okay, paid per hour. It's the money divided by hours. So in this case, she was paid $43.75 for 2.5 hours. If we divided that out, then we'll find the average that she was paid per hour. So 43.75, come on, fat fingers, divided by 2.5 is going to be 17.5. So that's 17.5, but remember the units are dollars per hour. And so I want to make sure I put that here. This is going to be dollars, so I'm going to add a 0 so that it looks right. $17.50 per hour. And notice I'm using the slash and the word per, again, interchangeably. So if you want to write the word per, if you want to use a slash there, which is division, either one of those is acceptable. All right, next one says find the average rate at which they completed problems per hour. So problems per hour, that means divide the number of problems by the number of hours. So in this case, there were 300 problems. Let me put the units there. 300 problems that were completed in 2.5 hours. And so that's going to be, let's divide 300 by 2.5, 120. And again, that's problems per hour. Problems per hour. Okay, we've got one more. It says to find the average amount of time spent per problem. So time per problem. That means put the time or the hours and then per problem. So time, or let's just say hours because it's the same. And now that's off-centered. And I don't know about you, but I don't like that. Okay, so time per problem. How much of the hours were spent on each one of those problems? So we had 2.5 hours spent on 300 problems. This is basically what we did on the last one in reverse. So, actually, Dividing 2.5, if we look at this, dividing 2.5 by 300 gets us this kind of an ugly number here. Would we want to say it's 0.0083 repeating hours per problem? That's a little bit of a tough concept to wrap our brain around. Like, what does that look like? 0.0083 repeating hours per problem. Let's see if maybe using the 120 problems per hour is a little bit more useful. So in the very last problem, we said 120 problems in 1 hour. So 1 hour, let me color coordinate again here. In 1 hour, there were 120 problems completed. Let's see if that looks a little nicer. 1 hour divided by 120 problems. Oh, look, same thing. But let's see. 1 hour for 120 problems. Maybe we could do... What can we do? How can we fix this? I got an idea. Maybe you're thinking of this too. 1 hour is the same as 60 minutes. So what if we made this 60 minutes for 120 problems? And this is not required. This is just to make an answer that seems a little more useful to look at. I think 60 minutes divided amongst the 120 problems means you're looking at half of a minute per problem. And we can maybe even make this seconds. Let's make this seconds. If we have 60 minutes and there are 60 seconds in each minute, we're looking at 3,600 seconds for the 120 problems, and I think this is going to get us to the best answer here. So let's say 3,600 divided by 120 is 30, so that is 30 seconds per problem. Now technically all of these would have been acceptable answers, but I like this one the best. It makes the most sense, 30 seconds per problem. Although, again, all of these would have been fine. So we could have said here, this was 0.0083 repeating hours per problem. That would have been okay. This was, what was 0.5 minutes per problem. That would have been acceptable. It's just, in my opinion, saying it took 30 seconds for each problem is a little bit more... makes a little more sense just thinking it out, okay? So all of those are fine, and, you know, it's not like you have to go through all those options, but I just want to show you that they're all fine. They're all rates. They all work, all right? Now let's look at one more problem here so we can connect this to some things that we've been doing before. So here it says, as a waiter, Andrew gets paid a fixed amount for a day of work, plus he earns an hourly wage. So Andrew shows up to work, they're going to give him some amount of money, no matter what, and then he gets an hourly wage on top of that. So his hours worked and corresponding pay is shown. It says for 2 hours worked, he's paid $45, and for 5 hours worked, he's paid $75. So first it says, how much is he paid per hour? So how much is he paid per hour? That means we have to divide the money by the number of hours. So what do we do? Any ideas? I'm sure you're thinking some things. So maybe you're thinking, okay, there's a total of 7 hours here, and there's a total of, let's see, that's $70, $110, $120 here. Maybe you're thinking, let's divide the 120 by 7, but the issue is we don't know how much the fixed amount is. So when it says that he worked 2 hours and got paid $45, some of that is an hourly rate, but some of that is that fixed amount, right? And the same thing with the 5 hours. Some of the money, some of that $75 was a fixed amount, and then there's an hourly rate. So what I would say is there's a difference of 3 here. So to go from 2 hours to 5 hours, there's a difference of 3 hours. And the difference here is 30 bucks. So if we changed 3 hours and $30, we can see exactly how much difference there was per hour. So there's a difference here of $30 in 3 hours, which means he had to have been paid $10 per hour. Okay, hopefully that makes sense there. And then we're going to look at this on the graph, and it'll make even more sense. So it says make a graph for Andrew's earnings each hour for the day. So it says for 2 hours, he was paid $45. So I'm going to go up here to 2 and 45, and I'm going to make that point. And then it says for 5 hours, he was paid $75. So I'm going to go here and make that point. And now if we looked at the pattern here, we can see what's going on here. Now we said that there was going to be a $10 increase per hour. So if 2 hours is 45, and that's correct, then going up to the next hour means he'd be increasing by another $10. And if he went another hour, that would be another, from 55 to 65, $10. And in fact, you can see how that lines up really nicely. So if we were to continue to make this graph, so these were the points that were given to us, and then based on the information here, if we go up by $10 each hour, we can see how that all lines up. And we can make as many points as we want here. Now we can see if he worked, let's say 6 hours, that he'd be making $85. Or if he worked 7 hours, he'd be making $95. Or 4 hours would be $65, and so on. Okay? And let's go ahead and plot the next one. If he worked 1 hour, he'd be making $35. And then if he worked 0 hours, he'd be making $30. Oh, just kidding. $25. Let's line that up. Okay? So it asks in the next part here, what is the fixed amount that Andrew is paid for the day? And how do you know? Well, remember, he gets paid a certain amount of money no matter what, and then he gets paid the $10 per hour. The certain amount of money he gets paid no matter what happens to be right here. So if he works 0 hours and still gets paid $25, that can't be an hourly rate. That's how much he makes for just showing up to work. So we have here, he's paid $25 is the fixed amount. Okay, based on the pattern. In the graph. Okay, we can see he gets $25 for 0 hours worked. Okay, so hopefully that makes a little sense. And if it's a little confusing, don't worry, but I do want you to just see how there's sort of a linear relationship happening here. Okay, notice that the relationship between the hours worked, which is what we graphed here on the x-axis, and the money that was earned, it changes at a constant rate. So 1 hour is $10 more, another hour is another $10, another hour is another $10. So what we have are these two variables that are changing at a constant rate. The rate of change with which one quantity is changing in relation to the other is constant. And that is the rate of change. The rate of change in the money earned with respect to the hours worked is constant. So when we have this constant rate of change, then the relationship can be represented by a linear function. When the rate of change between two quantities is constant, then the relationship can be represented by a linear function. Right? Think about those things that we've been graphing over the last few topics. If we were to connect these points, and we don't actually have to do this, but if we were to connect these points, we see a linear relationship happening there. And we're going to talk more about what the rate of change and that fixed amount represents in a linear function. But for now, just sort of familiarize yourself with the idea that if we have a constant rate of change, we're looking at a linear function. Okay? Now, for the most part for this topic, the important piece is being able to take two amounts, divide them to find an average rate of change, and make sure that your units sort of correspond with whatever you're dividing on the top of the fraction and then whatever you're dividing on the bottom. So if it's miles per gallon, then your units are miles per gallon, right? So just be careful with the units. Make sure you're dividing to find average rates, and then we will come back to this concept of constant rates of change and linear functions. Okay? So I think you have enough to get going for your practice, but as always, if you need some extra help, then feel free to reach out. All right, guys, take care.